2,000 years later.
Okay, so some of you have had some problems with this particular page. We did it last week. I did go over some of it, but I do want to kind of reiterate a couple things and also try to make this a little bit easier for you. I've got a method that I like using, and I want to make sure you guys are able to get to the right answer. Now, that could be in multiple ways. You could use by method, or you could borrow. That's one that I know that some of you have used. You could use fraction strips or models. There are a few different things you can do here. Now, for me, I find the easiest way to do this is to turn some of these fractions back into what we call improper fractions, and where the numerator, that top number, is bigger than the denominator, and then subtract that way. That works particularly well when you have a case where the numerator is too small in the first number, like this one, and you can't subtract the second numerator from it. So I'm going to go through these. I'm gonna do probably not everything on this page, but especially the independent practice section right here on the bottom of this first page. I will go through. So that's going to be. Let me go ahead and show you here. We are on page 521 if you're working out of the book. If you're working from the worksheet that I created in Google Classroom, then don't worry about the page number. Just worry that this is 910 subtracting mixed numbers. Okay, so for some of these, like for this one up here, that's going to be a little bit easier because you can see that you have your first numerator, this 5 right here, is bigger than your second one, which makes subtraction a lot easier, right? Because if we start with our whole numbers and do 7 minus 2, you've got 5, and then 5 minus 4, you've got 1. So then you know that for this one, your answer is going to be 5 and 1/8. Okay, so that's relatively easy. Now, for this one, this is where things get a little bit more complicated. You have a whole number, but you don't have a fraction here. Okay, so, and I've seen some of you get a little bit confused by this. So I'm going to show you a way to do this that I think is a lot easier, and it uses some of your other skills. Now, when you see a whole number like this, you know that means that you could have a fraction here. But the fraction would look something like this. You could have, if you wanted to, you could change this into 4, and because your denominator is 4 right here, you could say you have 4/4, because 4/4 is a whole. So if you had 4 and 4/4, that would equal 5. So let's leave it like that. Let's do it this way, and then do 2 and 3/4. Well, now this is easier, right? Because you have a 4 up here as a numerator, 3 over here. You can easily subtract those. You can easily subtract your whole numbers, 4 minus 2, and end up with 2 and 1/4. Okay, so that's the answer for that one. So that's what I recommend for those, and I'll go over that again. Now, here's the other one I was talking about. See these numerators? You can't take 8 away from 3, right? You can't. And as much as I know some of you want to go ahead and just reverse these, that's not going to work either. So you can borrow, but this is what I recommend doing with these. And I'm going to write it down right here. We're going to ignore these problems over on this side. And I'm going to write down what I consider a good formula for this, where you're going to take your whole number, so the number on the left, whole number, you're going to multiply it by your denominator, the bottom number, and then you're going to add the numerator. Okay? And you're going to keep your denominator the same. So I'll show you what that looks like. So let's work this one out over here on the right-hand side. So we've got 6, and this time we're going to take the 6, the whole number, we're going to multiply it by the 10, which is that denominator. You're going to end up with 60. Then you're going to add 3 to it, because that's the numerator, and you'll have 63. But you're not just going to keep it at 63, you're going to do 63 over 10. That's what I mean when I say keep the denominator. So we'll start with that one there. Now we're going to do the same thing with the other mixed number, this one right over here. So 1 times 10 is going to be 10, plus 8 is going to be 18. You're going to keep the denominator, so it's going to be 18 over 10. So now you've got 63 minus 18 over 10. Now all you have to do is figure that out. 63 minus 18. Some of you can do this in your heads. We'll go ahead and we'll borrow there. And then we'll figure this one out. And you've got 5. And now you've got 45. So you're going to end up with 45 over 10. Well, we don't want to leave it like this because this is still improper. So now we want to figure out how many times does 10 go into 45. Now, most of you can look at that and you can see that 10 goes into 45 4 times. So you've got 4. But how many do you have left over? So if it goes into there 4 times and you've still got that 5 left over, looks to me like you're going to end up with 4 and 5 tenths for your answer for this one. So this one is going to be 4 and 5 tenths. Now, like I said, there are other ways of doing it, but this is the one that I think is the easiest. Let's do it with number 6 as well. Okay, so for this one, I'm still going to do the same thing. I'm still going to have us multiply our whole number by our denominator and then add the numerator. But it does look a little bit bigger, right? So let's go ahead and see what we end up with here. 12 times 9. So 2 times 9, 18. 9 times 1 is 9, plus 1 is 10. So you have 108, but you're going to add that 4. And you're going to end up with 112, but we're going to keep the denominator. So you're going to end up with 112 over 12, okay? So keep that one in mind. Keep that there. Now let's work on the second one. Again, whole number, multiply by the denominator, and add the numerator. So 12 times 4 this time. That's going to be 8. 4 times 1 is 4. So you end up with 48. So we're going to end up with 48 plus, no, we have to add the 9. And you are going to end up with 57. So 57 over 12, because keep that denominator, right? So here we go again. We're going to do 112 minus 57. Let's borrow here. We'll do 12 minus 7 is 5. 10 minus 5 is 5. Now you've got 55. So now we ended up with 55 over 12. Well, we still have to simplify that, right? Because we've got an improper fraction where the numerator is too big. So we're going to look at how many times 12 goes into 55. So you can do that in a couple different ways, right? Most of you can look at this and you know that 12 times 2 is going to be 24. And you could do it this way. Add another 12, see what happens. You end up with 36. You still can do it again, right? Because 36 can go into 55, but it looks like you could add another 12 to that. Well, if you do, right, you're going to end up with 48. So you can't add another 12 past that. So now we know that it's going to be 12 times 4. So 4 is our whole number here. But what's left over? Well, what's 55 minus 48? Let's borrow this one. 7 here, 0. So you end up with 4 and 7 twelfths, which means the answer to this problem is 4 and 7 twelfths. Okay. And again, the reason that we did it that way is because you can't take 9 away from 4. And I know that a few of you, again, have been doing some different methods with borrowing and things like that. And you can continue to do that if that works for you. This is just one method I think is easy for a lot of students. Okay, so let's look at just a couple more of these. Let's scroll down because I've gotten some specific questions about some of the ones on the bottom here in our independent practice section. Okay. And we'll go ahead and erase some of our work over here so we have some space. Now let's take a look at these. Okay, so for the first one, now we're back to a subtraction problem here that's a little bit easier, right? Because you have a numerator here. The first numerator is already bigger than the second one. So you're okay to do this one as is, right? And you end up with 6 3/8. Okay, so fairly easy for that one. Now this one though, this is different, right? Because the 5 is smaller than the 9. So you're going to have to do something different here. So let's do the work over here on this side. Now I'm going to do the same thing. We're going to multiply the whole number by the denominator and add the numerator. So we'll do 10 times 4, which is 40, plus 5, which is the numerator, equals 45. Keep your denominator the same. So it's going to be 45 over 10. Okay, what about for the second one here? Okay, whole number, denominator, and the numerator. Okay, so now you've got 10 times 1 equals 10, plus 9 equals 19. Now you've got 19 over 10. So what is 45 minus 19? Let's borrow here. All right, look about right to you. 26. 26 over 10. Now, again, we still have an improper fraction, so we need to simplify this further. How many times does 10 go into 26? Well, most of you can look at that and see that it only goes in twice. And twice would be 20. Well, so what's left over after that? Well, you're going to know just by looking at it that it's going to be 6 left over. Sometimes it's a little easier with these problems that have a 10 as a denominator, because you can see pretty much right away what the answer is going to be. So 2 6/10. That's going to be our answer for this one right here. 2 6/10. Don't worry about simplifying that any further. We'll leave it as it is. Okay. Now I have gotten some questions also on number 11. And we'll do the same thing here. Let's go ahead and erase this. Okay, so you've got 4 1/8 minus 1 4/8. Same problem though. You cannot take 4 away from 1, right? And you can't reverse them or it wouldn't be the same problem. So we're going to do the same thing. We're going to take that whole number, multiply it by the denominator, and add the numerator. So we're going to do 4 times 8. And everybody should know what that one is, right? 32 plus 1. We're going to add for 33. Keep the denominator the same. So now you've got 33 over 8. Okay, now for the second one. So it's pretty easy, right? Same thing. Whole number, multiply it by the denominator, add the numerator. And that's going to be 1 times 8 is 8, plus 4 is 12. Now you're going to end up with 12 over 8. Let's do 33 minus 12. 21. 21 over 8. Now, same thing here. Now we need to simplify that. Let's turn that back into a mixed number. How many times does 8 go into 21? I think most of you looking at that know that it can only go in twice, and that's 16. So what's 21 minus 16? Let's borrow here. Okay, so now you know you're going to put 2 5/8, which means that our answer for 11 is 2 5/8. You've got 2 wholes and 5/8 as your fraction. Okay, let's do just a couple more of these with the slightly more confusing ones that have the whole number. Now, I know that a lot of you, when you see problems like this one, I saw it when I was grading a couple days ago. Oops, let's get rid of that mark there. It looks like it's going to be simple, right? You've got one whole number right here. You're thinking, oh, I'll just subtract the whole number from it. But you have to remember, you need to look at this one not as a whole number, but as a mixed number. So you're going to have to change it to something else. Now, what I recommend is you can see that we have a denominator of 5 right here. And you know what happens when you've got a 5 over 5. So assume that you've got at least one 5 over 5, right? 5/5. Then you're going to change this to a 5, okay? So now you've got 5 and 5/5, which we know wouldn't be right. It equals 6. But for the purposes of doing this problem, we'll do it this way. 5 and 5/5 minus 2 and 4/5. Well, now you've got a much easier problem because this first numerator is greater than the second one. So you already know you've got 1/5 here. And your answer is 3 and 1/5. A lot simpler than it looks, really. Let's do the same thing with this one. So you have 7 minus 3.5. Again, for some of you, I know some of you can do this in your head and you're looking at it and you're thinking, oh, this is already easy. But for some of you, I saw some struggling. So I want to make sure that we understand how to do this. Again, there are multiple methods, but this is the one that I think is the easiest. Okay, so assume, because we have 2 as our denominator here, that we're going to have, let's work this one out over on this side, that we're going to have at least 1, 2 over 2, right? Which means that this is going to not be 7 anymore. It's going to be 6. And then it's going to be minus 3 and 1/2. Well, now it looks a lot easier because you've got a numerator here that can actually be used. You can actually subtract this one from this one. So now you've got, you're going to end up with a 1/2 here. And you're going to end up with 3.5. And that is your answer for that problem. Okay, so hopefully that's making a little bit more sense. I know some of the ones down on the bottom are going to be a little more challenging, like this one right here. Yeah, 17 looks a little bit intimidating, right? Well, let's go ahead and work that one out just because it's going to be, I think it's going to help a few of you understand that one a little bit better. Okay, so let's scroll up here. And we'll work on that one. Okay, so now we've got 17 and minus 2 and 1/8. Well, our numerator is 8, right? So we already know that we're going to end up with, we'll have, if we want to break it back down, at least 1/8. Okay, now that means you're going to subtract 1 from this. So we've got 16 minus 2 and 1/8. Okay, so again, this one makes it pretty straightforward, right? 8 minus 1, it's 7, so you know you're going to have 7/8. And then 16 minus 2 is 14, so your answer is going to be 14 and 7/8. Okay, hopefully that makes a little bit more sense. Now, just to kind of round things out here, let's do number 22 because it looks a little bit confusing, and I know a few of you were a little confused. It's similar, but the whole number's on the other side. So let's go ahead and we'll do the work for that one right over here. Okay, so you've got 25 and 1/4, but what about that 20? Okay, again, our denominator right here is 4. So you know you're going to have a 4 on the bottom when we break this one back down. So you're going to have at least one that looks like this. And you're going to subtract 1 from here, so you're going to end up with 19, right? So now your problem looks like this. 25 and 1/4 minus 19 and 4/4. Well, you still have a problem, right? Because this numerator is less than this numerator, and you cannot subtract those. You can't take 4 away from 1. So we're going to have to do something else. Now, we'll use my method for this, and again, it's going to make it look intimidating, but it certainly isn't. And I think once you remember this one, you'll definitely get it. And I'm going to write it down right here as well. So whole number times the denominator plus the numerator. And you're going to have your new number on top plus your original denominator. Okay, and that's how you turn it back into what we call an improper fraction. So let's go ahead and do that. Okay, so we're going to do the same thing here that we've done. So we'll take 25 and multiply it by 4. That's our whole number multiplied by our denominator. So 5 times 4 is 20. Excuse that line right there. 2 times 4 is 8, plus 2 is 10, so you end up with that. And go ahead and add your numerator. You're going to have 101. But remember, keep that original denominator. So now you're going to have 101 over 4. Okay, so we already know that's how we're going to set it up. Okay, now let's look at the 19 and 4/4. Okay, so for that one, we're going to do the same thing. Take the 19, multiply it by 4, which is 9 times 4 is 36. So we'll put that right there. 4 times 1 is 4. 76 plus 4. And you're going to end up with 80. And you're going to have, that means you're going to have, we'll do it up here, 80 over 4. Okay. So now in that case, let's go ahead and erase a little bit here so we have a little more space. We're going to now do what we would normally do. We're going to take the 101 minus 80. It's 1. Could borrow here. It's 2, so you're going to end up with 21. And now we're going to keep that denominator the same, right? So you know this is going to be 21 over 4. Now you just have to figure out how many times 4 goes into 21. Well, most of you know just by looking at it that the answer is 5, right? Because 4 times 5 is 20. And you have 1 left over. So now you have 5 and 1/4. So that is your answer for this one, 5 and 1/4. So it gives you an answer that looks a lot different than what I think some of you thought it might look like when you first looked at that problem. But hopefully it makes a little more sense now that we've gone through it. Okay, so you're going to do the same thing for all of these. Again, I just want to remind you, I'm going to write it down one more time down at the bottom here, because I think this is going to help you. When you see a problem that looks like a lot of the ones we're seeing here, where the first numerator is too small to do a regular subtraction problem here, what I recommend is to take the whole number, multiply it by the denominator, add the numerator. It's going to give you a big number. It's going to turn back into what we call an improper fraction. Keep it over the original denominator, okay? And then you can work the problem out that way. But just remember, when you're done, you should always simplify again. Always break that back down into a mixed number, because you don't want to keep a number where the numerator is greater than the denominator. We always want the numerator to be smaller than the denominator, okay? So if you have any questions, just let me know.